Welcome to the fourth episode of SolTouch. Last time we discussed about ERC721 and about NFTs. There's another pretty common standard in NFTs, and its name is ERC1155. This standard is used for collections that have limited editions. So basically the main difference between these two standards is that ERC721 is used for generating unique tokens, each paired with an ID, as opposed to ERC1155, which is used to generate a limited edition of different types of tokens. So basically each entity is paired with an ID and an amount. We're gonna pass through the OpenZeppelin standard for ERC1155, and we're gonna start with the constructor of this function. So basically in the constructor you have to pass the base URL. The base URL is basically the place, the URL at which you will find the resources that the tokens minted represent. So basically if you create, for example, a collection of collectibles with let's say basketball images or basketball moments, you will find all the different types of basketball collectibles at a specific base URL. To that, you can concatenate usually the ID of the token and get the actual resource. For example, in the contract that we'll create today, this will be the base URL for our resources. We're gonna have two tokens. This is the first collectible, this is the first type of token, and this one is the second type of tokens. You can see here that for this one the ID is 1, so all the tokens with ID 1 will basically represent this picture, this collectible, and all the tokens with ID number 2 will represent this elf right here. Okay, so in the constructor you set the base URL from which you get the specific resources. This function is a function that checks for supported interfaces. For example, if you want to check if the contract supports the ERC1155 receiver, and this interface basically tells you if it's safe to transfer tokens to a specific contract, if it supports and knows how to handle that specific tokens. Here is a getter for the base URL. The balance of function works as follows. You send an account, you send an ID, and it returns the number of tokens with that specific ID that the address owns. In balance of batch function, you basically send an array of addresses, so let's say account 1 and account 2, and an array of IDs. They can be the same ID, and basically this function returns how many tokens with ID number 1 account number 1 has, and how many tokens with ID number 1 or 2 or whatever you put here account number 2 has. So that's balance of batch. Set approval for all is a function with which you grant the power to an operator to manipulate any tokens that you have stored in your address. So for example, if I call set approval for all with a specific address and with a true boolean, then that address will have the right to transfer my tokens from my address to another. isApprove for all is the function which checks if this approval was granted for a specific operator. Safe transfer from is basically the function which transfers the tokens with a specific ID and a specific amount of tokens from this address to this address. One interesting thing, and why it's called safe transfer from, is because this function also checks, using this function, do safe transfer acceptance check, if the contract, if the address that we want to send our token to is a smart contract, and if that smart contract knows how to handle the tokens that we are transferring to it. So moving on, the next function is safe batch transfer from, which is pretty intuitive. As opposed to the safe transfer from, it transfers from a specific address more tokens, so more types of tokens. For example, if you call it with this parameter for IDs and with this parameter for amounts, it transfers 100 tokens with ID 1 and 200 tokens with ID 2 to a specific address. The set URL function is an internal function that can be called just within this contract or the contract that inherits from this contract, and it sets the base URL of the contract. If you want, for example, the owner to be able to change the website at which users find their resources, you can implement a function in your contract that is callable just by the owner, which sets this new URL. You might need this, for example, if you at some point anticipate that you might have to change your domain or move the resources to another web address for some reasons. The mint function allows you to create tokens with a specific ID for some account, and also this data parameter allows you to bind some data to those types of tokens. It's an internal function, so you will have to create your own mint function in your contract that inherits from this Open Zeppelin standard. Mint batch does the same thing, but means different types of tokens. So for example, if you have an empty contract and you accommodate like 10 types of tokens in that contract, you can call the mint batch function in the constructor of the contract and start with a specific number of each token in the owner's address, in the deployer address. Burn burns the tokens, so removes them from the market. You can call this function with an account ID and amount, but it's again an internal function, and you'll have to implement it yourself in your contract, and be careful how you handle it. Because this burn right here can receive any account and burn the tokens from that specific account. So you want to make sure that if you make the burn available for everyone, you want to make sure that they can burn only from their address. Burn batch is the same thing, but burns many different types of tokens. Before token transfer is a useful function that you can override. So if you want a specific action before each transfer or each mint done in the contract, you can override this function here in your contract and do that specific set of actions before any transfer is called or any mint is called in the contract. So let's say that we want to, for example, emit a very custom event when any transfer or any mint happens. We can override the before token transfer function and emit that event in our contract. Do safe transfer acceptance check. We already talked about it. It basically verifies if you send tokens to a smart contract, if that smart contract implements the proper interfaces and knows how to handle receiving such tokens. Because if a contract doesn't know how to handle these tokens, so it simply receives tokens but doesn't have a function with which you can work, you can do something with those tokens, then they might be locked forever in that specific smart contract. So that's really not a thing that we want. So it's good to do safe transfers, which also call this function. This is the same thing but for batch transfers, and this is an auxiliary function that creates an array with one element from a single element, and this one right here is used in before token transfer, so you don't have two before token transfers, and this before token transfer by receiving only arrays is able to work with both safe transfer and safe batch transfer. Good, so this is our implementation, our collectible, which implements the Open Zeppelin standard. We can see here that we pass the name, the symbol, and the URL to the constructor. We save the name and the symbol into state variables, and we call the constructor of the Open Zeppelin contract with our base URL that we receive as a parameter to the constructor. We also need a mint function because right now there's no token whatsoever created by the contract. So we also need a mint function which will be available only for the owner to call. To dive a little bit into the ownable contract again, this contract sets the deployer of the contract as the first owner and also implements a modifier that we can use for our function, which checks if the caller of that specific function is the owner of the contract. For example, a renounce ownership can only be called by the owner who already has the ownership. A transfer ownership is another example of function that can be only called by the owner. So we'll need this modifier here so we can make sure that only the owner of the contract can create tokens. If we, for example, do not want the owner to mint the tokens, we can mint them here in the constructor. Let's say we want to mint token with ID 1, token with ID 2, and these are the amounts that we want to mint. We can already do so in the constructor, and the contract will start with that number of tokens owned by the sender of the constructor transaction, of the deployment transaction. Okay, so let's check this. Let's deploy this on Rinkaby, and let's also verify the code after we deploy it so we can access that pretty interface from Rinkaby. This is the migration that we're using. Here we provide a name for the contract, which is SolTouch collectible, and here we provide a symbol for the contract and the base URL. So the contract will have this variable. Since name and symbol are public variables, getters will automatically be available for these variables. So keep in mind that each time you have a state variable which is public, you will have by default some getters available for you. Okay, so it passed the try run, and right now is trying to deploy the actual contract, saving the migration. The contract will be available at this address right after it was deployed. I would like to take this opportunity to go a little bit again through the truffle config. Keep in mind that if you work with Git and you have this truffle config file, you should be very careful not to commit your mnemonic phrase, especially if you're using it to actually store some Ethereum or whatever. It might be sensitive and you might not want to do that. In the truffle config, you generally keep the mnemonic phrase. I define some plugins. Here, truffle plugin verify is the exact thing with which I verify the sources on Etherscan using this plugin and this API key. And in the networks parameter, you set the parameters for the network. So provider is based on what mnemonic phrase you offer to it and what JSON RPC you provide to it. In our case, we use an ep4 node to deploy our contract. You specify also the gas limit for the deployment. So if it consumes more than this amount of gas, then the transaction will be reverted. And we also specify the gas price which we're paying for our deployment for each unit of gas actually from our deployment. So our contract is ready. It can be found at this URL. Since we called the constructor and the constructor had a mint function, we should be able to find some tokens with ID 1 already minted on our address. So yeah, there we go. We have 100 tokens with ID 1 and we should have 200 tokens with ID 2. If we want to further mint some tokens, we can mint them, let's say, on our address. Let's mint tokens with ID 2, and let's mint another 20 tokens of this type to our address. Alright, so the transaction initiated. It's still waiting. Yep, and it's done. Now we have 220 tokens. We can set approval for an operator and allow that operator to move our token move our tokens from here to there. We can also move them ourselves by calling the safe transfer from with our address. If you call the safe transfer from function with your own address, it will skip the approval check, so it will automatically allow you to transfer these tokens. So that's pretty much about it. I will take some seconds to tell you about the usefulness of these tokens. These are used, for example, in limited edition collections. Let's say you want to collect some cards with basketball players, for example. NBA's Top Shot is a good example of this because they have a standard similar to what ERC1155 is. So, for example, you can have collectibles which are moments of basketball players recorded in the actual NBA games, and for each moment there are some number of tokens minted and offered to the community, and later they can be traded and so on and so forth. So basically ERC1155 is really a nice substitute for the classic cards that you collect and exchange with your friends and keep for value increase or whatever. You can use this standard of Open Zeppelin. I generally recommend, especially if you are not very experienced in blockchain development, to use the Open Zeppelin libraries, because these guys know what they're doing and they're implementing some really useful and nice smart contracts for the community to use. That was it for today. Next time we're gonna talk about how you test a contract, because the biggest flaws in blockchain development are bugs. Once deployed, you cannot come back as you do in the classical programming and patch and fix the bugs. So testing is a big part of Solidity development, and next time we're gonna go through how we test a smart contract before deploying it on the mainnet. That was it for today. Thank you and see you next time.